Lesson 9 for quadratics and the quadratic formula. At this point, you should have already worked on quadratic equations, solving them with completing the square and factoring. The quadratic formula is just another way to solve a quadratic equation, and this allows you to solve quadratic equations that are non-factorable, that have no real solutions, or that aren't solved easily with completing the square. Basically, this will work for any quadratic equation. So we talked about completing the square, and this is what was used to derive the quadratic formula. We're not going to go into all of that, but basically they took the completing the square, left a, b, and c in instead of numbers, rearranged that to solve for x, and came up with the quadratic equation, or sorry, the quadratic formula. So remember, the standard form of a quadratic equation is ax squared plus bx plus c, where a, b, and c are real numbers. And by completing the square, they came up with the quadratic formula. Now, there's a couple ways to memorize the quadratic formula, and the two that I like the best, there's a song and there's a poem. The song is sung to the tune of Pop Goes the Weasel, and it goes like this. X equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. So basically all you're doing is you're singing the formula to the tune of Pop Goes the Weasel. So do that one more time. X equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. Now another way to remember it if you're not into singing, there's a story. A negative boy couldn't decide whether or not to go to the radical party, but he was square, so he missed out on 4 awesome chicks, and it was all over by 2 a.m. Now both of these can be found all over the internet, so if you want to find a written copy, you can do so that way. We're going to be more concerned with using the quadratic formula, but to use it you need to know it. So it can be used to solve any quadratic equation, any, whether it has real solutions, whether it's factorable, whether it doesn't have real solutions, any quadratic equation. So again, here's our quadratic formula. So the first step is we need to set the equation equal to 0. It must be in the format ax squared plus bx plus c equals 0. Of course, these pluses could be minuses, but this has to be 0. So if it's not equal to 0, you need to rearrange it to make it equal to 0. Then we plug in the coefficients that represent a, b, and c. So we take these numbers with their associated signs, positives or negatives, and we plug them in b, a, and c here. Then we simplify to find the solution or solutions for x. Now most of the time there will be 2, but sometimes you'll have 1 or none. So for example, we're going to solve 4x squared plus 3x minus 5 equals. Now this is already set to 0, so that part's done. We don't have to worry about that. So now the next thing we're going to do is we're going to take our quadratic formula and we're going to plug in 4 for a, 3 for b, and negative 5 for c. Don't forget that if there's a negative, you need to bring that with you. So negative 3 plus or minus the square root of 3 squared minus 4 times 4, that's a, times negative 5, that's c, all over 2 times 4, which is a. Now if your b is negative, you have a negative negative, which will become a positive. So don't forget that. Next, we need to simplify underneath the radical. 3 squared is 9. Negative 4 times negative 4, or positive 4, is negative 16. So let me just write this off to the side. So that gives me negative 16 times negative 5, and that's going to give me a positive 80 over 8. So I have negative 3 plus or minus the square root of 89 over 8. And let me just double check my math on this. 4 times 4 times 5 is 80. Okay, 89. 89 is a prime number. Since 89 is a prime number, I cannot divide by anything. I cannot simplify it. This is my final solution. My two answers are -3 plus the square root of 89 over 8 and -3 minus the square root of 89 over 8. But we can keep it in this format. We can have one, two, or no solutions when we're solving quadratic equations. And I shouldn't say no solutions. I should say no real solutions. Okay, the graphs of each of these situations look like the following. If I have no real solutions, that is because I am not crossing the x-axis. My solutions exist here. If I have one solution, that is because I'm touching the x-axis in one place. And if I have two solutions, that is because I'm touching the x-axis in two places. And all quadratics give us a parabola. So the shape will always be the same. It's the arrangement or the placement that will change. We can determine if we have one, two, or no solutions by looking at what's known as the determinant. And the determinant is the portion of the equation located under the radical. Okay. The part located under the radical is b squared minus 4ac. So if we take b squared minus 4ac, the answer to that will give us how many solutions we have. If we have a negative number, there are no real solutions because you cannot take the square root of a negative. If you get a 0, it gives you one solution because the square root of 0 is 0. And so if you have b plus or minus 0, it's just b. And then a positive result gives us two solutions. Okay. So what we're going to do is we're going to look at some equations. And we're going to use the determinant. Again, remembering the determinant is b squared minus 4ac to determine how many solutions there are for each of these equations. So our b is 8, -8 rather. So I have -8 squared minus 4 times a, which is 2, times c, which is -24. And this is going to give us 64. And then I have 4 times 2 times 24. Negative times negative is a positive. So that's going to give me a positive 256. So there are going to be two solutions. Okay. Next one, I have b squared minus 4 times a times c. So 36 minus 4 times 1 times 13 is 52. That is going to result in a -16, so there will be no real solutions. Our next example, I'll have 10 squared minus 4 times a times c. That will give me 100 minus 100, resulting in a 0. So there will be one solution to this equation. And finally, b squared minus 4 times a, times c gives me 16 minus 12, which gives me 4, which is positive. So this equation would have two solutions. Now, why is this helpful? First of all, it helps you to know if you're working the problem correctly, because if you are only supposed to have one solution and you come up with two, you know you've done something wrong. Second thing is if I know that I have no real solutions because I get a negative determinant, I don't need to do all the work with the entire quadratic formula. I do the determinant, I see that it's negative, and I know that there are no real solutions. I write no real solutions and I move on. Okay, we're going to take these same equations now, and we're going to solve them. First, I'm going to write down my quadratic formula. Now, do you remember Have we had any solutions here? Let's double check. No solutions on that one. So I don't even have to solve this one. I can just write no solutions. Maybe I should keep that with no real solutions. But this first one, we have two solutions, so we need to solve this. So I have negative b, which is negative negative 8, plus or minus negative 8 squared minus 4 times a times c, all over 2 times a. So that gives me 8 plus or minus the square root of 64 plus 192 over 4. 64 plus 192 was 256. And the square root of 256 is 16. So I have 8 plus or minus 16 over 4. Now at this point, I need to do 8 plus 16 and divide by 4. And I need to do 8 minus 16 and divide by 4. 8 plus 16 gives me 24. And 8 minus 16 gives me negative 8. So my two solutions are 6 and negative 2. And I knew I was going to get two solutions because my determinant was positive, and that told me two solutions, and I got 2. Okay. If you recall, this one was going to give us one solution. So I have negative b plus or minus the square root of b squared minus 4 times a times c. And I already know that results in a 0. So I have negative 10 plus or minus the square root of 0 over 2. And here's why this 0 is going to give us only one solution. Negative 10 plus or minus 0 over 2 is just negative 10 over 2. That gives me a solution of negative 5. That is the only place that the parabola will touch the x-axis is at negative 5. And here's our last problem. Negative b, so I have a negative negative. B squared minus 4 times a times c over 2 times a. That gives me positive 4 plus or minus the square root of 16 minus 12 over 6. That's 4 plus or minus the square root of 4 over 6. 4 plus or minus 2 over 6. So I'm going to have 4 plus 2 and 4 minus 2 over 6. That gives me 6 over 6 and 2 over 6. So that's 1 and 1/3. This one, as you can see, would not have been as easily solved by factoring, just because of the fractional answer. But we did get our two solutions. Now, when do you use each method? Okay. If you have a 0 as your determinant, okay, also known as your radicand, it's the number underneath the radical, you know you have one solution. So you're going to have basically a perfect square trinomial, and you have one solution. These are easily solved by factoring. Now, if this is a perfect square and it's greater than 0, you're going to have two solutions. And because it's a perfect square, you're going to get real rational solutions. And factoring should be relatively easy. Or you can use quadratic formula if you want. Now, if you have a non-perfect square, you're going to have two real irrational solutions. In this case, completing the square or the quadratic formula are the best choices. And completing the square is the best choice if b is even, because you know you have to divide it by 2. That's when completing the square works best. And if you have less than 0, we're going to have no real number solutions. So in Algebra 1, we're just going to say no real solutions. Once you get into Algebra 2 or later math, then we're going to talk about imaginary numbers, in which case you would continue to solve this with completing the square or the quadratic formula. But we're not really getting into that at this level. So actually, at this point, you would just write no solutions and move on. And that's how to use the quadratic formula.